थियो नेपाली अब झण्डा उचाल्छ खुकुरी छ कम्मरमा
dark matter and dark energy in a simple language. Okay, I'll try to make it as simple. Okay, so when we talk about our universe, all the matters that exist in our universe are categorized into two parts. One is normal matter and another is dark matter. So what is the difference? Normal matter are those matters that can be detected and that interacts with electromagnetic radiations, right? So just you can see me, you can see this mic, right? You can see him, we can see everything because of the interaction with electromagnetic radiation. Because see, I can see you because there are photons coming out of you that reach to my eyes, and I see you as you, right? And you can see this mic because there are photons coming out of this mic that reaches your eyes. When photons reach your eyes, you will see it as mic, right? In this way, EM waves reach to our eyes and we detect it as some instrument, as matter, as anything. But in case of dark matter, dark matters doesn't interact with any range of electromagnetic radiations. Okay, so what does this not interacting mean? Not interacting means that dark matters don't absorb EM radiations. Okay, dark matter doesn't reflect EM radiations and dark matter doesn't emit radiations. Okay, so it doesn't absorb, it doesn't reflect, and it doesn't emit. In this way, dark matter doesn't interact with EM radiations, and not interacting with EM radiations makes it very difficult to detect. And till date, we haven't detected any dark matters, any particles that would resemble dark matter. So question might arise that if we can't detect it, if we can't see it, then how do we even know that it exists, right? So it shows its gravitational behavior. Okay, although dark matter doesn't interact with EM radiations, it shows its gravitational effects. Like whenever we talk about planets, okay, Earth has certain speed at which it revolves around the sun. Mercury has its own speed, Venus has its own speed, right? And that is due to the distance from sun and mass of the sun, right? The speed depends on distance from the sun and mass of the sun. Okay, similarly, when we talk about galaxy, there is a supermassive black hole in between at the center, and stars are revolving around the black hole. And when we study the speed of stars at the outskirts of galaxy, then we find that it doesn't match with our prediction. When we predict its motion based on the mass of the black hole, mass of the whole galaxy, and its distance from the center of the black hole, it doesn't match with our prediction. So after it didn't match with our prediction, we introduced dark matter. We say that there are matters that exist, but we can't detect it, we can't see it. That is why it is called dark matter. Okay, that is why it is called dark matter. So there are various predictions, there are various theories which explains about the particles of which dark matter are made of. Okay, there are various predictions, there are a number of theories, but I would like to talk about one of the most discussed concept, that is WIMP. WIMP stands for weakly interacting massive particles. So weakly interacting massive particles, and these particles weighs several times more than proton, and it interacts with weak nuclear forces. Okay, so it is one of the candidates of explanation of dark matter, and there are like several researches, several experiments going on all around the world to detect dark matter. And we already discussed about Large Hadron Collider, and in similar way Large Underground Xenon and Dark Energy Survey are some of the experiments that are going on with the main objective to detect dark matter. So, but we are not successful yet. We haven't discovered any particles that would resemble the existence of, that would point the existence of dark matter in a more strong way, in a stronger way. So yeah, this is how I could do it, as simple when it comes to dark matter. And moving on to dark energy. So what is dark energy? Dark energy is a component of the universe that is responsible for accelerating expansion of the universe, and that is dark energy. And dark energy is spread uniformly throughout the universe. Okay, and how did we come to know about the existence of dark energy? This is a long story. I would like to keep it in short. Okay, when Albert Einstein was working on his theory of relativity, he reached to a conclusion where he had to introduce a cosmological constant to counterbalance the effect of gravity and make the universe static. Okay, so in those times there's an understanding of the universe, that the universe is static. So he introduced the cosmological constant to keep it with the current understanding. Okay, but later when Hubble's telescope made an observation of the distant supernova which was receding away from us, and it observed that the galaxies were like moving away from each other, at that time we came to know that universe was expanding. And at that point there is a time when we came to know that universe was expanding. Albert Einstein admitted introducing the cosmological constant to be his life's like biggest mistake. But later on we came to know that universe was not just expanding, it was expanding in an accelerating way. The expansion was an accelerating expansion, and again at that point we needed the cosmological constant that we had dropped due to our understanding of expanding universe. Again that was introduced to explain the accelerating expansion of the universe. And this is so telling in short, dark energy is a component, okay, is a component that causes the universe to expand in an accelerating way. And when we talk about dark energy, there are various interpretations about dark energy as well, and most convincing to most of the people is the one given by quantum field theory. According to quantum field theory, the vacuum that we call to be a vacuum is not an empty space. Vacuum are not empty space. There are like when we like absorb or study vacuum are actually there are like particles and antiparticles. There are pair of particle and antiparticles that pops in and out of existence. Like they exist out of nowhere, they appear out of nowhere and they vanish into nowhere. And vacuum energy, so This leads to vacuum energy, and vacuum energy is pointed to be one of the like explanation for dark energy. And also there is an interpretation of dynamic field called quintessence. It explains dark energy to vary with time. It says that dark energy vary with time, and the accelerating expansion that we are observing these days didn't exist like from the beginning. It has become more dominant in the recent times. So this is about dark energy, and it is also being looked after. There are various researches looking after the existence of dark energy. We know about dark energy survey. We know about the dark energy spectroscopic instrument that is like looking after the evidence for the existence of dark energy. And but when we physicists, like we and our team, sit around and discuss about dark matter and dark energy, sometimes we have a kind of question, like as we understand the universe using the glass of general relativity, right, theory of relativity. So if we are not understanding the universe based on this glass, then there are chances that if we change this glass, or if we make any modification in this glass, then we could understand the universe in a better way, and we could even solve the mysteries that has been mysteries from centuries and centuries. So yeah, this is all about dark matter and dark energy. So moving on to the next question.
उठ्यो नेपाली अब झन्डा उचाल्छ खुकुरी छ कम्मरमा